Here we'll try and explain what an acidic buffer does and the two ways in which we can make it. So an acidic buffer will consist of a weak acid and its salt. An example of that would be ethanoic acid and its salt being ethanoate ions. So what does a buffer do? A buffer resists changes in pH if we add a small amount of acid, which will be in the form of hydrogen ions, or alkali in the form of hydroxide ions. When we add acid, the part of the buffer which responds will be the salt, and if we add hydroxide, then it's the weak acid which will react with the hydroxide ions. So with the acid, this is the equation that takes place, and with the salt we get that. So let's have a look at those two equations. We can see in the first one the ethanoic acid will slowly turn into ethanoate ions, and in the second one our ethanoate ions will generate a little bit more ethanoic acid. So we've got a seesaw between these large reservoirs of ethanoic acid and ethanoate ions, and if they don't change greatly then the pH will pretty much remain the same. We're going to look at two ways to make an acidic buffer. Now, bearing in mind that for an acidic buffer we want carboxylic acid and some of its salt, perhaps the most obvious way would be to simply mix together a weak acid, so for example ethanoic acid with some of its salt, which may well be sodium ethanoate. So just simply mix those two things together in a beaker and you will have an acidic buffer. The second way will involve a reaction. So we've seen already that in doing titration with a weak acid and a strong base, this could be one of the reactions that we do with ethanoic acid and sodium hydroxide. If we remind ourselves of what the pH curve looks like for that, so we'd expect to see pH curve along those lines. Now, if you take this region of the curve, as soon as we start reacting, then we start to get rid of our ethanoic acid and we start to generate sodium ethanoate. So the region that I've highlighted there on the titration curve, we've actually made an acidic buffer. So method 2 is to take an excess of a weak acid and add some strong alkali to it, and you'll generate an acidic buffer.